Hello friends, greetings of the day. Welcome to the online session of business economics. Friends, you know that we are learning chapter number 3, theory of production and cost. And in that chapter, we have started unit number 1, that is theory of production. In this session, theory of production, we have already completed the meaning of production, types of utility, and we have already covered the factors of production. Now friends, our next title is production function. We have already completed production, meaning of production. Now we want to learn what is production function. Friends, you know that production is conversion of inputs into outputs. When inputs are converted into outputs, that is considered as production. But now we want to learn production function. Simply stated, production function is the relationship between inputs and outputs. Production function is nothing but the relationship between inputs and outputs. Now what do we mean by relationship of input and output? It means that with the limited amount of input, how much amount of output can be generated. Here we just have to understand that limited amount of input we have, and with this limited amount of input we have to produce maximum amount of output. So the relationship between limited input and maximum output, this is known as a production function. Now the maximum amount of output that can be produced with given quantities of input, that means given quantities means fixed quantity of input. It means that we have fixed limited input. With this limited input, maximum amount of output has to be generated. How can this be possible? This is considered as production function. So production function is nothing but the relationship between limited input and maximum output. But we have to produce this maximum output under the given state of technical knowledge. That means the technology should be fixed. The technology that we have utilized, it must not be changed during the production function. So the technology that we have available, with that technology, with limited input, we have to produce maximum amount of output. So again, it can be presented diagrammatically here. The limited input we have, and on that limited input will make the process, and with that we will get the maximum amount of output. So limited input and maximum amount of output, relationship between these two is considered as a production function. Now according to Samuelson, what do we mean by production function? According to Samuelson, he has described that production function is the relationship between the maximum amount of output that can be produced and the input required to make that output. That means again it is the same thing, input required to make that output and maximum amount of output. So it is a relationship between input and maximum amount of output. This is known as production function, but again it is given state of technology. Given state of technology means technology must remain fixed during the production function. Next, according to Richard Leftwich, production function is applied to the physical relationship. Friends, you must remember that production function describes physical relationship. Otherwise it can also be known as a technical relationship, or it can be known as a functional relationship. Three options can be given: physical relationship, technical relationship, and functional relationship between input of resources and output of goods and services. So relationship between input of resources and output of goods or services per unit of time, leaving the prices aside. That means during a fixed time period, without considering the price of the product, we need to understand the relationship between input and output. This relationship between input and output is known as production function. Now through the equation, this production function can be described as Q is equal to F into bracket A, B, C, D up to N. Now these A, B, C, D, N, these all are inputs. Now on these inputs we make function, that is process. and as a result of this process we get quantity, that is output. So input, process and output, again this is known as production function. So Q stands for quantity of output, and A, B, C, D up to N, they all are inputs required to make that output. So we can say that this is a functional relationship. Now assumptions of production function. The first assumption is, we assume that the relationship between input and output exists for a specific period of time. That means we have to produce maximum output with limited input, but within how much time? That time period must be fixed. It can be 1 month, it can be 6 months, it can be 1 year, and within that 1 year, say for example we have fixed a time period of 1 month. So within that 1 month, limited input must have generated maximum output. Then and then our production function can be successful. So time period must be specified, it must be fixed. Next, it is assumed that there is a given state of the art in the production technology. Given state of the art is technology. The technology is given and fixed. We do not have to change the technology again and again. So for example, we have established the production function for 1 month. Within 1 month, we will utilize this input and will make maximum output. So during that 1 month, the technology must remain fixed. We cannot change technology in between. Within 1 month, that input, that technology must be fixed, and with that technology only we will try to create maximum output. Then whatever input combinations are included in a particular function, the output resulting from their utilization is at the maximum level. So we have to assume that the input combination can be changed, and with that input combination we will try to achieve the maximum level of output. Now production analysis. We have to understand two types of production analysis. One is known as a short run analysis, another is long run analysis. Now short run analysis is named as law of variable proportion. Short run analysis is named as law of variable proportion, whereas long run analysis is known as return to scale. Long run analysis is known as return to scale. Short run analysis is known as law of variable proportion. Friends, do remember other names of law of variable proportion. Law of variable proportion is also known as return to factor. Once again, I am speaking, law of variable proportion is otherwise known as return to factor. This is known as return to scale, but this is return to factor. And another name of this is law of diminishing return. This is also a name which is commonly used. It is law of variable proportion, it is return to factor, and it is law of diminishing return. Now this law of variable proportion is divided into three stages. The first stage is law of increasing return, then law of decreasing return, and then law of negative return. Under long run analysis, we know that it is return to scale. Return to scale is divided into three stages: increasing return to scale, decreasing return to scale, and then constant return to scale. So two types of analysis, short run analysis and long run analysis. These two are in our syllabus. Now before we learn what do we mean by this law of variable proportion and return to scale, we must understand what is a short run and what is a long run. Now on the basis of this understanding of short run and long run, we'll be able to understand law of variable proportion and return to scale. So let us first understand what is short run. Now in economics, short run or long run, they are not defined on the basis of time period. They are not defined on the basis of calendar time or clock time, but they are defined on the basis of factors of production. Let us understand. Short run is the time period in which output can be changed by changing only the variable factors of production. Once again, if we want to increase the output, we can change only the variable factors of production and fixed factors remain fixed. That means we are not able to increase the fixed factors in order to increase the output. We are able to change only the variable factors, and with the change in variable factors only output can be changed. Let us take one example so that it can be very much clear. As you know that in order to make the production, two types of factors can be there, fixed factors and variable factors. Now with the help of these fixed factors and variable factors, we need to make the production. So for example, this machine is a fixed factor for us, and on this particular machine 3 laborers can work. Say for example, at the initial stage on this particular machine we have applied one laborer. One laborer is applied, he has made the production, has sold out into the market, and still there is a demand for our production. We need to increase the production. So what shall we do? Shall we bring a new machine or shall we implement a new labor? So definitely students, we will implement a new labor, because still there is a chance to increase production by changing the variable factor only, because in this particular machine, as I said, 3 laborers can work. So we have applied only one until now, still one more can be applied. So we have changed the variable factor here. 2 laborers are working here on this machine. Both of them are working very hard, and whatever is produced by them, this is all sold out into the market. Still there is a demand. Still we want to increase the production. What shall we do? Shall we increase the number of machines or shall we increase the number of labor? Definitely friends, will increase the number of labor. Third labor is applied. Third labor is applied. All the 3 are working well, and the production made in this is all got sold. Everything is sold out into the market, and still there is a demand. Now what shall we do? Shall we bring a new machine or shall we bring a new labor? Now if we bring a new labor, it will not going to increase the production, because the capacity of this machine has been exhausted. As I said in the initial level, that this machine is having the capacity to work with 3 laborers. Now all the 3 laborers are applied, so we have to bring out new machine. And when we bring a new machine, it is the change in fixed factors. When we change the fixed factor, it becomes long run, because in long run we will be able to change fixed and variable both. But here until now we have changed only variable factors. So by changing the variable factor only, fixed factor remains fixed and variable factors are changed, the production is increased, and this is known as a short run. Now let us understand what is long run. Long run is the time period in which the output can be changed by changing all the factors of production, that is fixed factor and variable factor, in the same proportion. That means we can change both variable factor as well as fixed factors in the same proportion. It means no factor remain fixed. Now again let us take the example. Now this is a machine, and on this machine only one labor is capable to work. Now this is a small machine, and on this small machine only one labor can be occupied. So one machine and one labor, whatever production is made, this has whole got sold. Now we want to increase the production. Shall we increase labor only or machine only? No, the answer is we are going to increase both of them. So again a new machine and a new labor, both of them are changed. That means we are capable to change both fixed factor and variable factor. The time period in which we can change fixed and variable both factors, this is considered as a long run. Now we are working with 2 machines and 2 labor. All the production has got sold, and still there is a demand of our product. We want to increase the production. Again we bring a new machine and a new labor. So we are changing both the factors of production, that is fixed factor as well as variable factor. So the time period in which we can change fixed as well as variable both, this is known as long run time period. Now one equation we have to understand, that is Cobb-Douglas production function. Friends, two American economists, C.W. Cobb and Paul H. Douglas, these two economists had studied the production system in America, and on the basis of their study they have derived a formula. This formula is Q is equal to K into L raised to A C raised to 1 minus A. Now Q is quantity of output, L is quantity of labor, C is quantity of capital, K and A, these are positive constants. Friends, they have suggested that if a factory or any productive unit wants to increase the production, they must utilize the factors of production according to the proportion given by this function. If any factory utilizes the factors of production according to this equation, they will be able to increase the production. So on the basis of this equation, if production is made, the production will be increased, and they have found out the conclusion through this equation. They said that if we produce through this equation, the production will increase, and in that increased production, labor's contribution will be 3/4 and capital's contribution will be 1/4. It means that labor is more efficient as compared to capital. Labor is more efficient because it has contributed 3/4 in the increased production, and capital has contributed 1/4 in the increased production. So labor is more productive as compared to capital. This was the conclusion derived by Cobb and Douglas through this equation. Friends, here in this particular section you have to remember the equation, and you have to remember the contribution of labor and contribution of capital. That's all. So that's all for now. Thank you.